Let us discuss this question. Obtain the particular solution for the following differential equation using method of undetermined coefficients. We have like three questions. This is our first question. So when we talk about this is y double prime minus 2y prime minus 3y is equal to 2 exponential 4x. You can see that this is second order non-homogeneous. Why? Because our g of s here is not equal to 0. And I explained in our previous lesson on second order homogeneous that if our g of s is equal to 0, if g of s is equal to 0, we'll call it homogeneous. And if our g of s is not equal to 0, we'll call it non-homogeneous. So you can see from this question that here is not equal to 0, is 2 exponential to the power of 4x. So this is second order non-homogeneous. So for us to solve a second order non-homogeneous, we have to use what? Method of undetermined coefficients to solve it. So what are we going to do now? This is ay double prime plus by prime plus cy is equal to 0. So you can see that it's in form of what? It's in form of what? Homogeneous. But here is not what? It's not 0. It means for us to solve this, we have to consider, we have to solve the homogeneous. We have to solve the homogeneous. Then after we solve the homogeneous, we will now solve the what? Non-homogeneous part. We will consider that our first one to solve the what? Homogeneous part, and the second one is what? To solve the non-homogeneous part. Okay. So this is what? This is the general form of second order homogeneous. So you can see that our a is what? Y prime. So it's in form of this is equal to 0. It means our solving here will now be y prime plus minus 2y prime, y double prime minus 2y prime minus 3y is equal to 0. So we have to solve the homogeneous part. So let us solve the homogeneous part then. After we solve the homogeneous part, we now solve the what? Non-homogeneous. You can see that our g of s is equal to 0, that is homogeneous. So what are we going to do next is what? We assume that, remember that what's our y prime prime? This is our second, that is the second derivative. This is a what? First derivative. And our second derivative take m, while our what? M to the power of 2, while our first derivative take what? M, while our y here take what? 1. So I see y double prime, I'll make it m squared. Whenever I see y prime, I'll make it what? M. And whenever I see y, I'll make it what? 1. So from here, how do we get this? I've explained earlier in our what? In our homogeneous, second order homogeneous, that is, we assume that, or let assume that y is equal to what? Exponential ms. If I differentiate this, I'm going to have y prime m exponential mx. Then if I differentiate this one again, I'm going to have m squared exponential ms. You know how we got this? When we're dealing with exponential, we differentiate the power with respect to x. I'm going to have what? M, then multiply everything. So it means whenever I see y double dash, I'm going to put this. Whenever I see y prime, I'm going to put this. Whenever I see y is equal to exponential s, I'm going to put it in this equation. So therefore, I'm going to have m exponential ms, m square exponential ms minus 2y prime. Our y prime is what? M exponential ms minus 3. What is my y? My y is what? Exponential ms is equal to what? 0. Because we have to solve the what? Homogeneous part. So what is next? I will divide both sides by what? Exponential ms. This will cancel, this will cancel, this will cancel as well. So I'm going to be left with m squared minus 2m minus 3 is equal to 0. You can see that it forms an auxiliary equation. And when we talk about an auxiliary equation is an equation that is it forms a quadratic equation. That is, you can now apply a quadratic formula or a formula to solve the quadratic equation. So what we can apply using factorization method, we have to find the two numbers that if you add, we are going to have -2. Then if you find the product, we are going to have -3. So the number are -1 and what? 1 and -3. It means if we add 1 and -3, we are going to have what? -2. If you find the product of 1 and -3, we are going to have what? -3. I did the sum of this will give you -2. The product of these two numbers will give us -3. So we will now what? We will now replace it. M square minus m minus what? 3m minus 3. That is m we multiply by m, 1 we multiply by m, -3 we multiply by m, minus m minus 3 is equal to 0. So what are you going to have? I'm going to have m minus 1 minus 3 m minus 1 is equal to 0. If I use this to open this bracket, I'm going to have this. If I use this one to open this bracket, I'm going to have this. Plus 1 is plus minus 3 and minus 3, then minus times plus minus 3 is equal to. You can see that it is the same. M plus 1 is the same with this. I'm going to take it at once. So I'm going to have m plus 1, then m minus 3 is equal to 0. So from here, I will have m plus 1 is equal to 0 or m minus 3 is equal to 0. So I'm going to have what? My answer will be m is equal to -1 or m is equal to -3. So it means my auxiliary equation gave me m is equal to -1 or m is equal to -3. You can see that this case is a case 1. Remember that in our second homogeneous, we have 3 cases. 3 cases in second order homogeneous. That is, if our m1 or m2 is not equal to, so it means it's a real root distinct. It's a real root distinct. And we're going to have a general solution of y of s is equal to a exponential ms plus b exponential ms. So I can make m1 is m1 or m2. It's still the same thing. I can say this is m1, m2. Because our m1 and m2, you can see that here that our m1 is not equal to what? M2. If our m1 is not equal to m2, my general solution will be in this form. You can see that -1 is not equal to -3. So I'm going to have y of x is equal to, whenever I see m, I put -1. A exponential minus x plus b exponential 3x. This is 3. M is equal to 3. M is equal to 3x. So it means I have solved the what? I have solved the homogeneous part. That is, our g of s is equal to 0. So I will now what? I will now consider this part. So since this is y of x, I'm not going to have y of x here. Whenever we are dealing with method of undetermined coefficients, our solution will be y is equal to yc plus yp. That is, our solution will be yp plus yc plus yp. Our yc is our general solution of the ODE. Then our yp is what? The particular solution. So I'm going to have yc. That is, this is y of s. So I'm going to have yc, that is a exponential minus s plus b exponential minus 3s. So since my solution using method of undetermined coefficient, I'm going to have y is equal to what? Yc plus what? Yp. So it means I've gotten yc. So I have to find what? Yp. So my yp will not be when my homogeneous and when my g of s is not equal to 0. So I'm going to solve this part. So how am I going to solve this part? I will since my g of s is equal to what? 2 exponential 4s. You know that I've considered g of s is equal to 0. That is, I got where I got homogeneous, that I got my auxiliary equation. So I'm now going to consider g of s here, this right hand side, that is the right hand side that gave us, that we are given. So what I'm going to do here is what? Is to what? G of s is equal to what? 2 exponential 4s. And then my y, then my yp. What's my particular solution for this? So in second order non-homogeneous, there are some complementary factors that we have to consider. It means whenever we are dealing with brackets, whenever we are dealing with constant, my constant term will be, suppose I have 5 as a constant, will be a. Whenever I'm dealing with x, suppose my g of x here, is 5. My complementary factors of this, my complementary factors of g of x will be a. If my g of x here is what? If my g of x here is 5x or x, let's say x, my complementary factors of g of x will be ax plus b. If it is x squared, it will increase by the power of 2, ax squared plus bx plus c to the constant. If it is power of 3, I'm going to have ax cube plus bx squared plus cs plus d. And whenever I have exponential 4x, I'm going to have what? A exponential 4x. It means whenever I'm having exponential, my exponential will give me the same exponential. But what is here? The coefficient of exponential is 1. And our 1 is a constant, which is a. We multiply this. So it means if I have 2 here, 2 is a constant. The complementary factors of constant term is what? Is what? Is a. So I'm going to have a exponential 4x. So these are the what? These are the complementary factors. We have for sine, we have for cos. So when we get there, I will explain when to use sine, and when we have sine, what is the complementary factors that the particular solution will be. So it means I will now differentiate this. First, if I differentiate this, y prime of p, what am I going to have? If I differentiate with respect to what? Y of p. So if I respect to f, I'm going to have what? 4a exponential 4s. I'm differentiating this with respect to s. I will differentiate again. If I differentiate again, I will differentiate the power 4x, which is 4. Multiplied by this, I'm going to have 16a exponential 4x. It means I will now go to my equation here, that is my equation given to me. I will now substitute this into this equation. So y double dash, that is y double prime, is what? 16a exponential 4x minus, what is my y prime? My y prime is 4a exponential 4x, then minus 3. What is my y? My y here is what? There's y of p. A exponential 4x is equal to what? Is equal to what? 2 exponential 4x. Because I want to get y of p, I will differentiate this twice because of this equation. So that's how to solve this. So I'm going to what? So let me open the bracket. I'm going to have 16a exponential 4x minus 2. That's 2 times 4. 8a exponential 4x minus 3a exponential 4x is equal to 2 exponential 4x. I can divide through by exponential 4x. Since exponential 4x is common between them, exponential 4x will cancel, exponential 4x will cancel. I'm going to have 16a minus 8a minus 3a is equal to 2. So 16a minus 8a, I'm going to have what? 8a. 8a minus 3a, I'm going to have 5a. 5a is equal to 2. So I want to get a here. So what is my a? I will divide both sides by what? 5. If I divide both sides by 5, I'm going to have what? I'm going to have a is equal to 2 over 5. A is equal to 2 over 5. So it means, remember that for us to get this solution, this is a non-homogeneous. It means I'm having y is equal to yc plus yp. That is, yc is my general solution for the homogeneous, which is this. Then my yp is what? My particular solution for the non-homogeneous. So it means I have to get my yp. So I will now go to yp. Where is yp? This is yp. A exponential 4s. So it means, what is my a? I've gotten my a here, 2 over 5. So my yp will now be 2 all over 5 exponential 4x. So my general solution for the non-homogeneous will now be y is equal to yc plus yp. So what's my yc? a exponential minus s plus b exponential 3x plus what's my yp? My yp is what? 2 over 5 exponential 4x. 2 over 5 exponential 4x. So this is the general solution to the what? To the what? Second order non-homogeneous. It means we have used what? We have what? We have considered non-homogeneous and it's homogeneous to solve this. That is y is equal to yc plus yp. So this is the solution. Let us now consider the second example.